Welcome to our poster. My name is Wang. Our work is about 3D object classification and detection in volumetric 3D CT baggage security screening imagery. This is a joint work with my colleague Dr. Neil Bhowmik and Professor Toby Breckon. We are with Department of Computer Science at Durham University. A few words about the background. This work arises from a real-world application in airports. When you go to airport before boarding, your bags and suitcases need to pass through an X-ray machine as shown in the image. The X-ray machine scans your baggage and generates an image like those shown in the bottom. Then, human operators will use their expertise to find out any potential prohibited items in the image. Currently, 2D X-ray machines are deployed in most airports in the world. In our previous work, we've developed automatic algorithms for prohibited item detection in 2D X-ray images and achieved high performance. However, one limitation in 2D X-ray images is that the prohibited items can be occluded by other objects in a cluttered image. One option to alleviate this problem is to use 3D CT images, which can provide more information to the human operators to avoid possible missing detection. With 3D CT images, one can rotate and check the image from different perspectives, which inevitably take more time. Our work aims to alleviate these issues by developing and evaluating approaches to automatic prohibited item classification and detection within 3D volumetric CT volumes for aviation security screening. There are some related work to 3D object detection in two areas: autonomous driving and medical image analysis. For autonomous driving, the data are usually in the form of point clouds or RGB plus depth, and the target objects of interest are mainly the road participants, including vehicles, pedestrians, cyclists, and so on. For medical images, there are CT, MRI containing organs and indicators of different diseases. There exist many works of 3D object detection in these two areas we can take advantage of, but at the same time, we need to be aware of the challenges posed by our spatial application. Different from the target objects in autonomous driving and medical image analysis, the prohibited items in baggage can be of various sizes and orientations in the baggage. Let's first focus on the classification problem. We use 3D CNN models, which take an isolated CT subvolume as the input, and output the probability of the input containing prohibited items or not. We consider different 3D CNN architectures, including ResNet 18, ResNet 34, ResNet 50, and Voxception ResNet, which is a combination of inception-style layers and skip connections. We also investigate different data augmentation strategies, such as rescaling the input volumes, and rotating the volumes within 3 planes by 90 degrees, 180 degrees, or 270 degrees. Finally, we consider the effectiveness of rich features, which is essentially a concatenation of multiple features from intermediate layers. We conducted experiments on 2 datasets, the Boulder dataset and Hang-On dataset. For each dataset, we cropped the subvolumes containing the target objects as positive samples, and subvolumes not containing the target objects as negative samples. As a result, the problem is formulated as a binary classification problem. From Table 1 and Table 2, we can see 3D CNN can achieve pretty high true positive rates and very low false positive rates on both Boulder and Hang-On datasets. And among different models, the Voxception ResNet performs the best. For detection, we investigated 2 object detection frameworks, faster RCNN and RetinaNet, with 2 backbones, ResNet 50 and ResNet 101. We tried different exercises and reported precision, recall, and average precision. In general, RetinaNet achieves higher recall while faster RCNN gives higher precision, and RetinaNet seems to be a better option in terms of average precision. Similar results can be achieved on Hang-On dataset, as shown in Table 5. Finally, we visualize the detection results by drawing 3D bounding boxes around the detected objects, as displayed in the video. To conclude, 3D CNN is promising for baggage screening within 3D city images. In the future, we would like to consider more types of prohibited items and formulate it as a multi-class classification or detection problem. And thank you for your attention. And if you have any questions, please do drop us an email.